Okay, good morning to everyone, students. Okay, I hope you have did the CA2 exam well. Okay, at the end of today's session, probably we will look about the answers for the CA2 questions. Okay, now we will move with the today's topic. So in the previous session, CA2 revision class, you all know. Okay, we have discussed about we have revised the portions which is for CA2, a partial portion we have revised. The other portions we hope we taken in a short period only, so you may remember those things. Okay, I hope everyone did the CA2 well. Fine. Before getting into today's topic, I want to ask some questions. Okay, you people can unmute and tell. Fine. So, what is the purpose of memory device? Can anyone say? Why memory device in general? Or else you can just type it in the chat. Yes, for storing information. Very good. Okay, for storing information. Most of the device, okay, most of the digital electronic device, okay, day-to-day device what we are using, it is essentially having a memory. For example, your mobile phone, laptop, computers, okay, even your washing machine, fine, everything it is having certain memory. So memory is used to store the information. The information can either a program or data, both can be stored. Program means whatever application you are opening in your system or mobile phone, fine, that installed application, that we call it as program, fine. Whatever the information you are inputting to the particular application, that we call it as data, fine. So that is the purpose of memory device, fine. My next question is, what is meant by address and data regarding memory device? Memory device பொறுத்த வரைக்கும் addressனா என்ன, dataனா என்ன? Can you people type it in the chat? Yes, location of the data, that we call it as address, the information what we are storing in the particular location, that we are calling it as data. Very good. Okay. Next. Can you type it in the chat? What do you mean by volatile memory? The term volatile memory. We are having two types of memory. One is volatile memory. What about the other one? Kindly type it in the chat. In the case of volatile memory, the information is maintained, okay, till the power is on. Say for example, when you are opening your computers, okay, when you are yes, very good, Srivabala. RAM is the example for volatile memory. Okay, when you are working with your computer, now I have opened browser, PowerPoint presentation, Paint, so many softwares. Okay, when I am opening the particular application, okay, the required thing for the particular application is copied to the RAM memory, that we call it as random access memory. Okay, the information will be retained in the RAM till power is on. Okay, suppose if I am closing some application, at that time you can have a pop-up. Have you seen that? Do you want to save or no? Have you seen that? Yes or no? Yes. Okay. That means whatever you are processing, it is available in the RAM only. When you are closing the application, whether it has to be saved to the hard disk or not. That's the pop-up it is asking. Okay. If you didn't save it, it won't be available for later use. Clear? So in general, RAM memory or the volatile memory holds the data when power is turned on. Okay. When you remove the power to the device or switch off the device, the information stored in the RAM will be lost. Okay, some random binary values will be stored in the memory location. Okay, you cannot predict it. Okay, that's why it is termed as random access memory. So you can access. That means there are two types of access in memory device. One is storing the information and retrieving the information. The process of storing the information, we call it as write operation. Okay, the process of retrieving the information is called read operation. In the case of RAM memory, you can do both. Fine. Then non-volatile memory. What do you mean by non-volatile memory? What do you mean by non? Yes, data is saved and hold, even power is turned off. Very good. Okay, see, power nama turn off பண்றப்ப நமக்கு என்ன இருக்கும்? Data will be stored in the storage device. Say for example, you have induction stove, okay, or refrigerator, or air conditioner, many devices which is having two types of memory. One is RAM, the another one is ROM. Fine. Those appliances, how it has to work, that program is generally stored in the ROM. Okay. For example, if you turn off your refrigerator for 2 days, whether its functionality will change when you turn it on again? Yes or no? See, na refrigerator vechirukren, so adula some embedded system irukku, so in that we are having memory. Okay, so they have written some program how the refrigerator should function. Okay, so in the level mela ponuchuna enak vandu compressor stop pananum, like that some coding will be there. That program is stored in the ROM. Okay, what I am asking is whether your appliance is behaving in different way after you turn off the appliance, and after some days if you turn on, whether the functionality will change? No, the functionality won't change. What it means? The program is permanently stored. Okay, in other words, we can say RAM memory is for temporary use, okay, whereas ROM is for permanent storage. Is it clear for everyone? Is it clear for everyone? Yes. Okay, so we are having different types of RAM memory. Okay, can you type it in the chat? What are the two types of RAM memory? Two types of RAM memory. Yes, SRAM, DRAM. SRAM stands for static RAM. Okay, DRAM stands for dynamic RAM. Okay, very good. Can you people tell what is the difference between static and dynamic RAM? Which one is faster? SRAM. Okay, so what about the cost comparison of SRAM and DRAM? Which one is costlier? Static RAM or dynamic RAM? DRAM is costlier. Can you type it in the chat? What is the reason for that? See, in the case of your computers and all, SRAM is costliest. Yes, very good, Srigari. Dynamic RAM is relatively less cost when compared to SRAM. Okay, fine. So, how many number of address line, data line, and size of decoder for a RAM of 2 power n cross m size? Can you people type it in the chat? 2 power n cross m, where 2 power n is the number of memory location and m is the size of each memory location. So, in our question in the question itself I have given the answer. How many address line and data line and size of decoder are available in the RAM of 2 power n cross m size? எத்தனை அட்ரஸ் லைன் இருக்கும்பா? If I want to address some 4 memory location, yes, very good, figure n address line. Okay, very good, n address line. What about the size of data line? The size of data line is equal to the word of the memory device. Here the word size of the memory is mentioned as m. So m is the number of data lines. Okay, what about the size of decoder? Decoder என்ன size இருக்குப்பா? 2 power n memory location select பண்ணனும். So அப்ப வந்து 2 power n output இருக்கணும் decoderல. So how many inputs must be there? Okay, I will tell the answer. N to 2 power n line decoder we have to use. Okay, fine. So the same thing I have asked with some values. How many address line and data line must be in a RAM of 64 kilobyte? So here I have mentioned byte, that indicates each data is of 8 bit. Okay, so 64k, K stands for 1024. That means 64 into 1024. 1024 can be 2 to the power 10. Okay, so 64 into 2 to the power 10 cross 8. Can you people type it in the chat? So 64k na eppadi eludhalampa? How I can write 64k? The screen is visible?
Yes, sir.
Okay, 64 kilobyte. How I can write? See, 64 we can write 2 to the power 6, correct? Then kilo means 1024, that means 2 to the power 10. Okay, so this is the number of memory locations available in the particular RAM cross each of 1 byte, that means 8 bit. Clear? So 2 to the power 16 cross 8 is the memory device. Can you type it in the chat now? 2 to the power 16 cross 8. Can you people type it in the chat? Yes, 16 address line. Very good. 16 address line. Okay. How many data lines? How many data lines must be there? 8 data lines. Very good. So what about the size of decoder we have to choose for this? Theoretically, what about the size of decoder we have to use for listening the same memory, 64 KB of RAM? Two power 16 cross 8, we have told 16 address lines சொல்லியாச்சு கரெக்டா? So 16 address line கொடுத்தனா decoderல எத்தனை output வரணும்? 2 to the power 16 வரணும்னு சொல்லியாச்சு. So what about the size of decoder we have to use in this case? Address line and select lines are same. That is your question. Okay. See, when teaching the memory device 4x4 RAM, we have told address line and select line. Okay. See, actually the select lines are given to the input of decoder. Okay. That will generate address output. Okay. So number of address line is nothing but the select line. Both are same only. Clear? சொல்றது புரியுதுங்களா? ஃபார் எக்ஸாம்பிள் 3 அட்ரஸ் லைன் இருக்கு அப்படின்னா எனக்கு மீனிங் என்ன? 8 அட்ரஸ் யூ கேன் ஹேவ். ஸோ அவுட்புட்ல நமக்கு என்ன இருக்கலாம்? 8 மெமரி லொகேஷன்ஸ் யூ கேன் செலக்ட். Select line and address line are same only. So we must be having a decoder of 16 is to 2 to the power 16 decoder. Okay. Then final question. Which signal is used as control line for read and write operation? The RAM memory design பண்ணப்போ சொன்னாங்க இல்லையா ஒரு block diagram. அதில் read and write operation whether we are having two different signals or same signal we are using. Which signal is used as control line for read and write operations? Kindly type it in the chat. Okay, anyhow, see, it is not a mandatory thing. Okay, but generally for read operation, the control signal use this RD or RW bar. I will type it in the chat. R/W bar. R/W bar. It will be like this. Okay, so if you keep the pin as 1, if you keep the signal as 1, so you are performing a read operation. If it is 0, you are performing write operation. Okay, what we have taught is like that. Generally, the read-write signals will be like this one. Read na generally ella edathilum enna pannuvanga 1 logic, write na 0 logic. Okay, you may design some memory device as Srihari told. Okay, andha mari panna mudiyum. Fine. Now we will continue with the ROM. Okay, so in the previous class we have discussed RAM memory and ROM memory. So the RAM memory classification paathachi. So in this class we will discuss what is ROM memory and what about the classification of ROM memory. So ROM is the storage device which is used to store the binary information permanently or semi-permanently. Okay. So permanent store பண்ணிக்கலாம் or else you can rewrite it. Okay. இப்போ நான் ஒரு கோடிங் எழுதி இருக்கிறேன் என்னோட ROMல ஜெனரலா நான் என்ன பண்ணுவேன் programs we will store or functionality of the device I will store. Fine. So if I want to change the functionality of the device, what I can do is I can reprogram or I can rewrite the ROM chip. Okay. So ROM is a storage device which is used for permanent storage. Okay. Generally it is used for permanent storage. Whenever it is required, you can rewrite the old program. Clear? Is it clear for everyone? See, those things you can easily understand when you are studying microprocessor and microcontroller. Okay. So அங்கதான் உங்களுக்கு ஸ்பெசிஃபிக்கா ROM அப்படின்றது வந்து ப்ரோக்ராமுக்காக, டேட்டா அப்படின்றது RAM அப்படின்றது for storing the data, like that we will teach you. Okay. As of now நமக்கு தெரிய வேண்டியது என்ன? ROM memory holds the data till you rewrite it, reprogram it. Rewrite to சொல்ல முடியாது, reprogram it. Once again we have to use some procedures to overwrite the content. But RAM is not like that. At any point of time, you can read as well as write the data into the RAM. Okay. The process of writing the data into ROM, we call it as burning process, something we will tell. Or uploading the program, something we will call like that. So ROM is a non-volatile memory. It contains decoder and OR gates in a single IC package. Okay. So it is like RAM memory only, fine, more or less. But the thing is, it is only meant for storing your information. Fine. Once you have stored, that means you can retrieve. You can able to only retrieve the information once it is stored. That means you cannot modify it unless it is reprogrammed. Okay, or burning with some new data. So ROM consists of n input line. Okay, for n input line, there are 2 to the power n address locations available with m output line, that we call it as data line. See, RAM or ROM both are having the same concept to incorporate the address and data. Okay, so இங்கே எனக்கு n address line இருந்துச்சுன்னா 2 to the power n memory location we can address. Fine. So the data or the word which is coming out of the memory device of m, size m. Okay. So the size of the ROM is specified by 2 power n cross m. As we told for RAM, here also we are having the same notation. Okay, fine. Now, so ROM la enalla irukum அப்படின்றது பார்க்கலாம். So it will be like this. It will be having n input address line and the m output data line. So in the n input அப்படின்னு சொல்றப்ப here we must be having a decoder. So say for example if substitute 3, so 3 inputs இருக்கு அப்படினா meaning என்ன? 3 address line இருக்குனா 8 memory location we can address like your RAM memory. Fine. ஏதோ ஒரு memory தான் at a time ல select ஆகும். Correct? Because we are using a line decoder. We have told you what you mean by line decoder. For any given combination of input, only one output will be high at a time அப்படின்னு சொல்லி கொடுத்தோம். Correct? So that will be used to select the memory locations. See, when I am teaching the decoder, there itself I have told you it is incorporated in memory devices for addressing. Okay, fine. So the selected memory, say for example, if I am having 8 memory location each of 8 bit, in the memory location select ஆயிருக்கோ அதுல இருந்து எனக்கு என்ன வரும்? 8 bits will be having. Fine. Next. So the ROM memory is classified into many ways. Okay, the most common things are maskable ROM, PROM, EPROM, EEPROM. Okay, we'll go one by one. Fine. So apart from this, we have a memory type called flash memory. Okay, the flash memory. Whereas in the case of EEPROM or EPROM, we have to write each and every bit. We have to erase each and every bit individually. Okay, but in the case of flash memory, a block of information. Say for example, வந்து பாத்தீங்கன்னா ஒவ்வொரு பிட்டா நமக்கு delete ஆகாது. நம்ம delete கொடுக்கறப்ப erase பண்றப்ப fine. The erasing time of the flash memory is faster when compared to this EEPROM and the EEPROM and all. Clear? So the erasing time பொறுத்த வரைக்கும் பாத்தீங்கன்னா flash memory are very fast. So நம்ம யூஸ் பண்ற pen drive இருக்கட்டும் fine. Most of the thing இப்போ வர மைக்ரோ கண்ட்ரோலர்ஸ் எல்லாத்துலயுமே பாத்தீங்கன்னா they are incorporating flash memory instead of EEPROM because the erase time is very less. Okay, now we'll go with the classification of ROM. So flash is another type of memory, okay, where you can store as well as retrieve. Both can be done. Okay, why it is termed with unique name means it can be accessed very faster. That means the erase time of the flash devices are very faster when compared to EEPROM or EEPROM. Fine. Now we will go with the maskable ROM. So maskable ROM. What do you mean by maskable ROM means this particular chip. Okay, this particular chip whose data in each location is fixed by the manufacturer itself. Say for example, I will draw a diagram here. I want to draw a diagram here. So I am having 4x4 ROM. We will assume. So we will be having 16 bits, correct? We will be having 16 bits. See, each box represents 1 bit location. You assume like that. Okay, this box represents a single bit location. Here what the thing will be is, I will draw for only one thing. You will be having a structure called fuse. Okay, it will be like this. Switch mari irukum namakku paakradhukku. Clear? For representation I am drawing like this, but actually inside you will be having some switching devices, electronic circuit da irukum, switch irukadu. Okay, you will be having some transistors. Okay, so like that every cells will be having. See, idhula engengala namakku vandu indha switch close agumo adukku enna technical name solluvaanga appdi pathina fusing appdi solluvom. Fusing, we will term it as fusing. See, whichever cell we want to write one, that cell should be masked. Masked means what? You have to apply some layer on the particular surface. Okay, there will be some provision for that. After that, it will be applied to a pulse. Okay, such that நமக்கு எங்கெங்கலாம் நமக்கு வந்து இந்த switch close ஆகணுமோ அந்த bits எல்லாம் எனக்கு என்ன ஆயிடும், close ஆயிடும். Remaining bits will be 0. Clear? Once இதல நம்ம எழுதிட்டோம் அப்படினா we cannot able to change it. Are you able to understand? It is a ROM memory. It is a ROM memory. Okay. During the construction itself, each and every bit logic must be decided. நீங்க எதுவுமே என்ன பண்ண முடியாது. You cannot able to write anything on it. Clear? So in this type, the programming is done by the manufacturer itself based on the truth table which satisfy your requirement. See, நமக்கு அந்த chip எப்படி function ஆகணும் அப்படிங்கற truth table நான் என்ன பண்ணுவேன், மெமரியில incorporate பண்ணுவேன். Say for example, if I am having a 3 variable, so definitely நமக்கு என்ன வேணும், 3 inputs வேணும், கரெக்ட்டா? So அப்ப output எத்தனை இருக்குன்னா 8 output must be there. So it will be like this. 3 input இருந்தா கண்டிப்பா எனக்கு என்ன இருக்கணும், definitely I will be having 8 combination output from the decoder. 8 output from decoder. See, I am speaking about the decoder. 3 inputs நான் கொடுக்கிறேன் அப்படின்னா எனக்கு என்ன வரும், 8 output இருக்கும், கரெக்ட்டா? Say for example, it will be like this. 1 2 3 4 5 6 7 and 8. So address இந்த மாதிரி வச்சுக்கலாம். 0 1 2 3, 4, 5, 6, 7. Okay, fine. So in the decoder la namakku vandu pathina how many number of outputs must be there for your particular circuit. Okay, say for example na or full adder design panna poren appdin vechingla appo enakku inputs enna a b c a b c. What about output? Output enakku ethana irukanum? See, what here I have told is decoder output, not the actual output of the circuit. Okay, decoder output. So it is for decoder. Fine. Okay, so actually enakku ethana output irukanum pa? If I am saying a full adder circuit, we will have two output. One is sum, the another one is carry. Correct? So appo na enna pannuva appdin pathina each memory location it is going to have only two cells, two binary cells. Fine. Ipo enakku truth table enna varum? In the case of my full adder circuit, I will be having one for, wait a minute, sorry, 1, 2, 4, 7. I hope you remember the min terms. 0, 1, 2, 4, 7. இது தவிர மத்த எல்லாத்துலயும் எனக்கு என்ன இருக்கணும்? 0. What about for carry? Carry எப்பலாம் நமக்கு வரணும்? 3, 5, 6, 7. கரெக்டா? 3, 5, 6, 7, 0. Fine. See, you consider this is a memory device. Okay, it is having totally 16 cells. So the size எப்படி சொல்லலாம் நம்ம? 2 to the power 3 cross 2. So for number of address line என்னது? 3. Okay, number of data lines என்னது? 2. Clear? So for meaning என்ன அப்படினு பாத்தீங்கன்னா, if you give ABC as 0, 0, 0. 0, 0, 0 கொடுத்தா எனக்கு எது செலக்ட் ஆகும்? This memory location will be selected. So இப்போ இதுல இருந்து வரக்கூடிய அவுட்புட் என்னது? sum. இதுல இருந்து வரக்கூடிய அவுட்புட் என்னது? carry. Fine. If I want to design a circuit like this, எனக்கு fixed logic எனக்கு வேணும் அப்படின்னா you can go with maskable. See, once in the binary pattern நம்ம எழுதிட்டா no need to change it. It will work as a full adder circuit. Okay, so இப்போ maskable ROM அப்படின்றது என்னது? Based on the requirement during manufacturing process itself, the ones and zeros are written in the memory locations. Okay, so the size of the word depends on number of output required for your logic circuit. Okay, the number of input decides the address line. Okay, so address line அப்படின்றது எதை டிசைட் பண்ணுது? number of inputs. Word lines or data lines எதை define பண்ணுது அப்படின்னு பாத்தீங்கன்னா number of output variables for your system. Okay, so it is expensive. Why it is expensive? See, if I want to design my own circuit, say for example if I am designing a circuit, it has to be implemented as a hardware. Okay, for manufacturing, while you are manufacturing, you have to do with large number of ICs. See, நான் ஒரே ஒரு IC இல்ல 10 IC மட்டும் நான் fabricate பண்றேன் அப்படின்னா எனக்கு காஸ்ட் வந்து ஜாஸ்தி ஆகும். Clear? So based upon the user requirement, if it is a bulk thing, the cost will be getting reduced, or else it is expensive method. Okay, see, இப்போ எனக்கு ஒரு டிவைஸ் நான் வாங்குறேன், அதுல நான் ப்ரோக்ராம் பண்ற ஃபீச்சர்ஸ் இருந்துச்சுன்னா ஓகே. If it is not like that, if it is decided at the manufacturing process itself, okay, so we must be very careful. So நமக்கு திரும்ப அதோட ஃபங்க்ஷனாலிட்டி சேஞ்ச் பண்ண முடியாது. So what we have to do? We have to throw that and we have to do another thing. So that's why it is expensive. So it is irreversible. That's what I told you. Once it is fixed, the logic is fixed, you cannot change it. Once the unit is programmed, the fixed pattern is permanent. Is it clear for everyone? Is it clear for everyone? Can you people type it in the chat? Yes, okay. Next, PROM. Okay, so maskable ROM means we cannot be able to program it. Just during manufacturing process, the logics must be fused. Okay, whereas in the case of PROM, we can able to program the memory. Okay, programmable read-only memory. That's why it is having the name PROM. Okay, programmable read-only memory. Here also we are having ROM only. Okay, it is a type of ROM memory. That means what? You can able to read the content of the memory once it is programmed. Is it clear for everyone? This type of ROM allows user to program the unit. நான் program பண்ணிக்கலாம். Say for example, உங்களுக்கு வந்து ஒரு memory chip இருக்குன்னு வச்சுக்கோங்க. Say for example, wait a minute. The screen is visible for all of you. Okay,
yes,
okay,
sir.
okay, ma'am. Thank you. Okay, this type of ROM allows the user to program the unit. Okay, so a PROM idella later nama paakalam. Fine. As of now, what we have to know is what about the operation? Just the functionality eppadi irukundradhu mattum paakalam. Okay, fine. Say if I am having an 8x8 memory PROM, 8x8 irukku nama consider pannikalam. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 and 8. Okay. See, if there are output lines from Korupa, can you people type it in the chat? I may not be able to see the chat. Can you people unmute and tell? So totally I am having 8 memory locations, 0, 1, 2, 3, 4, 5, 6, 7. So 7 memory location. What about the number of output lines? 8 output lines, 8 data lines, correct? Okay, so using this particular PROM, you can design any circuit which is having 3 variables as input and 8 output variable. Clear? You consider this is Y0 and you consider this is Y7, sorry, D0, D7. So this memory chip is definitely provided with a decoder of 3 to 8. 3 to 8. So we'll be having 3 input lines that we call it as address line or select line. Okay. So here we will be having 8 lines which are connected to each memory location. See, for your understanding purpose only I am telling. See, if I am having a 8x8 PROM, what are the circuits you can able to build? Only 3 inputs. Okay, 3 input variables are irukka mudiyum. What about the number of outputs? 8 varaikku nama kondu polam. Say for example, idha vechi na enna circuit build pannalam appdi pathina, we can build half adder, okay, full adder we can build. If na half adder porappa na enna pannuva appdi pathina, we will be having only 2 inputs. So for address line enakku enna irukku? A2, A1, A0. Clear? If my circuit is having only 2 inputs, you can use this 2 lower or the LSB of your address line. Okay? So inga neenga input enna combination koduthalum half the memory da use agum 0 to 3 varaikum. Correct? So output la nama enna pannikalam 8 outputs la edho rendu mattum nama eduthikalam to design a half adder. Full adder porappa nama enna pannalam all the 3 address lines you can apply the variables. Fine, you will be having only 2 outputs. See, nalla gavanikanumpa எனக்கு இதுல வர டேட்டா லைன்ஸ் மொத்தம் எத்தனை இருக்கு? 8 இருக்கு. ஃபைன், ஆனா என்னுடைய சர்க்யூட்டுக்கு 2 தான் போரும் அப்படினா you can just program those memory cells alone. Other things we no need to program. That can be a don't care things. Fine, appropriate உங்க சர்க்யூட்டுக்கு ஏத்த மாதிரியும் PROM யூஸ் பண்ணலாம். or else இருக்கிற சைஸ்ல what it is possible. Okay, I will ask you one question. Can you people type it in the chat? I will ask you one question. If I am having a PROM of 16 cross 8, okay, what is the maximum number of input variable and the output variable for the circuit? I am having 16 locations, 16 memory locations. Very good, Srihari. 4 inputs only you can give. Okay, because if you are having 16 memory location, to select that 16 memory location, you will be having only 4-bit address. Okay, that means 4 input variable your system can have. And what about the number of outputs? 8 outputs you can have. 16 cross 8 only 4 input variables and 8 output variables you can have. So maximum combination of solder. Maximum 4 variable, 8 variable, 4 variable input, 8 variable output vara mari circuits nama design pannidom. Okay, see, to choose the size of the PROM, you have to understand this concept. Okay, I will ask you one more question in the chat. You people try to answer. I am having a 64 class 4 PROM. Okay, 64 cross 4 PROM. What about the number of input variable and output variable? You can design a maximum using that. 6 is the correct answer for input variable. Okay, 4 is the number of output variable. See, ஒரு circuit நான் design பண்ணனும் PROM use பண்ணி அப்படினா, we have to know this thing. Okay, so how the size of PROM can be chosen for designing a circuit. Okay, I will continue. So the programming is done by the current pulse. Okay, you can write some program. See, நமக்கு என்ன bit pattern வேணுமோ அதை நான் binary information store பண்ணிட்டு systemல இருந்து நான் என்ன பண்ணலாம்? I can program it by applying some current pulses. Okay, so it is irreversible like maskable. That means one time programmable. Okay, PROM பொறுத்த வரைக்கும் நீங்க என்ன பண்ண முடியாது? You cannot reverse the logic, but you can decide any logic. Whereas in the case of maskable ROM, during the manufacturing process itself, the logics are fixed. Whereas in the case of PROM, it is programmable by the user only, but it is one-time programmable. That is the difference between maskable ROM and the PROM. Is it clear for all of you? 10th slide. Okay. Can you take a screenshot, Sabarish? See, while solving problem solve பண்றப்ப இந்த PROM லாம் உங்களுக்கு எப்படி choose பண்றது எல்லாமே புரியும் உங்களுக்கு கண்டிப்பா. Okay, don't worry about it. So the third thing is erasable, programmable, read only memory. Fine. So இதுக்கு முன்னாடி நம்ம பார்த்த device, I mean maskable ROM and PROM both cannot be erased and rewritten. Okay, first one la program பண்ண முடியாது. Fine, maskable ROM you cannot able to decide the logic once it is fabricated. During fabrication process itself, it has to be decided. Okay, in the case of PROM, you can decide the logic, but only one time you can program it. Fine. See, that is the disadvantage of those devices. Such things are absolute now, almost absolute. PROM, maskable ROM, இதெல்லாம் வந்து பாத்தீங்கன்னா almost எங்கேயுமே இப்போ யூஸ் பண்றது கிடையாது. Rarely it may be used in some hardware, some circuits. Okay, so EEPROM. Okay, EEPROM, after EEPROM came, we have an advantage. Okay, see, once I have programmed my appliance or device, I can change the program as many times that is possible, but that too we have some life cycle. Say for example, 10,000 times we can write, like that they will mention, or 1,000 times we can write that, like that they will mention. Okay, up to that time only we can able to erase and write. Fine, we cannot write like your RAM memory. RAM memory la நம்ம எழுதுற மாதிரி இங்க டேட்டா எழுத முடியாது. Here we have to completely erase the memory, then we have to write. Whereas in the case of RAM, it is not required. At any point of time, you can write any data in any memory location. You can read any memory location. That's your choice. Okay. Whereas in the case of ROM memory, especially in EEPROM, before writing any content to the EEPROM, it must be erased. Okay, all the things must be erased. While erasing, you can have two options: erase all binary cells with logic 1 are all binary cells with logic 0. That depends on the programming. Okay, are you able to understand what I am speaking? Erase na namakku enna theriyum ellame zero pandrathu. It's not like that. Erasing means you are filling either with ones or zeros. Clear? அது பேர் என்ன சொல்லுவாங்க அப்படினு பாத்தீங்கன்னா fused bit அப்படினு சொல்லுவாங்க. That we call it as fused bit. So அதெல்லாம் technical terms. Later part of your program you can know about that. Okay, microprocessor, microcontroller வரப்ப அது பத்திலாம் clear-ஆ தெரிஞ்சுக்கலாம். Fine. As of now, EEPROM அப்படின்றது என்னது? User can program the unit. It is reversible and reprogrammable. Clear? எத்தனை தடவை வேணாலும் நான் என்ன பண்ணிக்கலாம், பழைய மாதிரி கொண்டு வந்துக்கலாம். Just by erasing, it becomes a normal condition. Again, you can program it. Fine? Okay. EEPROM பொறுத்த வரைக்கும் the writing process or burning the data or program, it is normal. Okay. So we have to erase it to reprogram it. அப்ப அந்த erasing procedure எப்படி பண்றோம் அப்படினு பாத்தீங்கன்னா placed under ultraviolet rays for a period of time. Say for example 15 to 30 minutes உங்களோட ஐசியை வந்து நீங்க என்ன பண்ணணும், ultraviolet rays subject பண்ணீங்கன்னா அதுல உள்ள content எல்லாமே erase ஆயிடும். Fine. Even though you can erase the data in EEPROM and reprogram it, the erasing procedure takes more time. Is it clear for everyone? Okay. We have EEPROM chips in our college laboratory. Okay. If possible, okay, kandipa வந்து நீங்க processor படிக்கிறப்ப you will show this thing. Okay. Even if we people forget, you can ask, sir, EEPROM எப்படி இருக்குன்னு எங்களுக்கு பார்க்கணும், காமிக்கிறேன்னு சொல்லிருந்தீங்க அப்படின்னு கேட்டீங்கன்னா we will definitely show it. Okay. So the EEPROM chip பொறுத்த வரைக்கும் I will draw a diagram. We'll be having a IC only. EEPROM அப்படின்றது just ஒரு chip தான். Okay. Can have many pins on either side of the ICs. Normal IC மாதிரி தான் இருக்கும். Fine. So here you can have a window. Okay. So quartz window அப்படின்னு சொல்லுவாங்க. Quartz window window. So here you can have a transparent thing on the top of the IC. உங்க IC மேல பாத்தீங்கன்னா ஒரு window இருக்கும். Clear? இந்த windowல தான் உங்களோட chip என்ன இருக்கும், fabricate பண்ணிருப்பாங்க. I mean below that window only your chip is fabricated. If it is exposed to ultraviolet rays, all the content, okay, all the content present in the memory, it is erased. It gets erased. Okay. So the design, when the EEPROM is designed, at that time itself it is fixed. Erase பண்ணா எல்லாம் 0 ஆகுமா 1 ஆகுமா அப்படின்றது fixed. I'm sorry for that. Fuse bit அப்படின்றது EEPROM ல கிடையாது, EEPROM ல. I'm sorry for that. Okay. In the case of EEPROM, you have fuse bit. You can make it either 1 or 0. Whereas in the case of EEPROM, simple EEPROM, it is decided during the manufacturing process. எனக்கு இந்த விண்டோ வழியா நான் வந்து ultraviolet rays பாஸ் பண்ணனா எனக்கு எல்லாமே 0 ஆகுமா 1 ஆகுமா, it is decided during the manufacturing process itself based upon the type of semiconductor material and the configuration used in it. Fine. We are not detailing going to study about its construction. Fabrication பத்திலாம் நம்ம இங்க படிக்க போறது இல்ல. We have to understand the basic concept of EEPROM. That is the ultimate aim for us. Okay. So in the window வழியா நம்ம ultraviolet rays பாஸ் பண்ணோம்னா the chip will get erased. Fine. Okay. Can I ask you one question? Can we use the EEPROM chips normally like other chips, or something we have to do with it? The EEPROM chip இருக்கு இல்லைங்களாப்பா, ஸோ இதை யூஸ் பண்ணி நான் வந்து ஒரு பர்டிகுலர் லாஜிக் டிவைஸ் நான் பண்றேன் அப்படின்னா நார்மல் டிவைஸ் மாதிரி அந்த ஐசி யூஸ் பண்ணலாமா, ஆர் சம் அதர் திங் we have to do with it? இப்போதான் கொஞ்ச நேரத்துக்கு முன்னாடி சொன்னோம் how the data can be erased, how the information in EEPROM can be erased. The data in EEPROM can be erased by what? By subjecting what? Using ultraviolet rays. Okay. Using ultraviolet rays. Okay. Okay. Suppose if I didn't close the window, what will happen? அந்த ஐசியில் உள்ள விண்டோ நான் க்ளோஸ் பண்ணலன்னா என்ன ஆகும்? In normal condition, in ambient light, okay, நம்ம நார்மல் ரூம்ல உள்ள லைட்ல கண்டிப்பா என்ன இருக்கும்? It is from the sunlight only, correct? So definitely it is going to have ultraviolet rays. So all the data stored in the EEPROM may get accidentally erased when it is subjected to sunlight also. Okay, so what we have to do? Once it is programmed, we have to enclose the window with some material. Okay, either you can have some stickers to be pasted on the window. Are you able to understand what I am saying? Erase பண்றப்ப மட்டும் நம்ம என்ன பண்ணணும்? இந்த window நம்ம இது பண்ணிட்டு you can place it in ultraviolet rays. In normal usage time, it must be enclosed with something. Okay. So the last one is EEPROM. So EEPROM பொறுத்த வரைக்கும் பாத்தீங்கன்னா it takes more time to erase. Say for example, 15 to 30 minutes it takes to erase the entire memory content. Okay. So உங்களோட data sheetல it is mentioned. நீங்க ஒரு EEPROM IC நீங்க பாக்குறீங்க அப்படின்னா the data sheet it will be mentioned. Okay. Now EEPROM அப்படிங்கிறது electrically erasable programmable read only memory. After this memory came, okay, we have more advantages. Means no need to place the chip in ultraviolet rays to erase the content. Using some electrical voltage itself, we can erase the content. Clear? So that means fast erasing when compared to EEPROM. EEPROM is erasable and programmable, whereas EEPROM is or E square PROM can also be termed as E square PROM. Okay, E க்கு மேல ஒரு ஸ்கொயர் போடுவோம் இல்லையா? A square B square like that. You can also write E square PROM. Fine. EEPROM can also be termed as E square PROM. So in the case of E square PROM or EEPROM, it is similar to EEPROM only. The data erasing process, okay, that can be done with some electrical signals. Pulse mari nama apply pannona, it will get erased. Please remember one thing, whenever you are writing something to EEPROM, definitely the content must be erased and it has to be stored. The new thing must be stored after erasing it. Fine. Now we are having a new terminology, programmable logic device. Okay, so இப்போ நம்ம பார்த்தோம் இல்லைங்களா, maskable ROM, PROM, EEPROM, EEPROM. இதுல எதெல்லாம் programmable? Can you people type it in the chat? ROMலே நான் 4 கேட்டகரி சொன்னேன், கரெக்டா? இந்த 4ல எதெல்லாம் programmable? Can you people type it in the chat? Programmable logic device is nothing. It is very simple. Normally நம்ம என்ன சொல்றோம் அப்படினு பாத்தீங்கன்னா, the programmable logic device must have a provision to program, okay, in a way user required. EEPROM you can program. What about PROM and EEPROM? That is also programmable logic device only. Okay, fine. Now we will go with the programmable logic devices. So before that, we have to know what are the different types of logic devices. There are 2 types. One is fixed logic devices. The another one is programmable logic devices. Fixed logic devices, it is going to work for a single functionality. Once the construct pannittom appadina, it will behave like that only. All the combinational logic circuit, you can surely call it as fixed logic devices. For what you have designed, that logic it is going to function. That logic only it is going to work. In that logic only it is going to work. That we call it as fixed logic device. What about programmable logic device? At any point of time, you can change the functionality of the device by writing some program. That's why it is called as programmable logic devices. Is it clear for everyone? Is it clear for everyone? See, programmable logic device அப்படினு சொன்னா கண்டிப்பா அது என்ன இருக்கணும்? There should be some provision so that I can able to program that chip. Okay. Fixed logic devices, say for example, ஒரு 4-bit binary adder circuit IC எடுத்துக்கிட்டீங்கன்னா, it will work for that only. That is fixed logic devices. For that purpose only you can use that logic device. Whereas programmable logic devices பார்த்தீங்கன்னா, ஒரு PROM வச்சு நான் full adder பண்ணலாம், half adder பண்ணலாம், full subtractor பண்ணலாம். Okay. Whereas 4-bit binary adder I can construct, 4-bit binary subtractor I can construct. Any type of logic circuit we can implement using this PLD. Okay, now so fixed logic device அப்படினா என்ன சொன்னோம்? A circuit in which the logics are permanent. They can perform only one function or set of functions. Once manufactured, they cannot be changed. Whereas in the case of programmable logic device, the circuit in programmable logic device can be programmable as per our requirement. நமக்கு எப்படிலாம் வேணுமோ அந்த மாதிரி நம்ம என்ன பண்ணிக்கலாம்? We can write the programs. Right? So it is an IC with internal logic gates that are connected through electronic fuse. That's what I told. Okay. So the fuse வந்து நம்ம blow பண்ணோம் அப்படின்னா connection வந்து establish ஆகும். So the main advantage of PLD approach is it can be easily configured by the individual user for specific application. Okay. So we are having a variety of programmable logic devices. So the major classification என்னென்ன இருக்குன்னு பார்க்கலாம். So PLD has an AND array and OR array to provide an AND OR sum of product implementation. Any Boolean function you can do it in canonical form. Canonical form la rendu paathom. Enna paathom pa? Sum of product of sum rendu paathom. Fine. So ipo enak AND array OR array irundha podum. We can first perform the AND operation. The AND terms again enna panikalam? We can sum it up. Okay. So that we call it as sum of product. To implement sum of product, we are having two types of array. One is AND array. So AND array is used to perform the product operation. Fine. The OR array is used to perform the sum operation. So sum of product means we can do with a PLD which has AND array and OR array. Okay, so that you can perform any AND OR operation. AND OR means sum of product operation. புரிஞ்சுதுங்களா? இங்க பாத்தீங்கன்னா n இன்புட்ஸ் இருக்கு. கரெக்ட்டுங்களா? n இன்புட் அப்படின்னா எத்தனை அவுட்புட் நமக்கு இருக்கலாம்? இதுல ப்ராடக்ட் டர்ம்ஸ் இருக்கலாம். k number of product terms. It need not to be 2 power n. 2 power n is the maximum combination. கண்டிப்பா வந்து எனக்கு எல்லா அவுட்புட்டுமே ஜெனரேட் பண்ணனும் அவசியம் கிடையாது. Will be having AND array, OR array. ரெண்டு அரே இருக்கும். ஃபர்ஸ்ட் நான் என்ன பண்ணனும்? என்னென்ன மின் டர்ம்ஸ்லாம் வேணுமோ அத நான் என்ன பண்ணிக்கலாம்? Using this AND array I can perform. Fine. After that product terms are generated, adha edella sum pannumo adha na enna panikalam? Using OR array you can sum it up. So all the PLD devices must be having an AND array, OR array rendume. Fine. But in all the programmable logic device idu rendume program pandra mari irukadu. Fine. In some of the PLDs AND array mattum program pandra mari irukum. In some of the PLD device OR array mattum program pandra mari irukum. In some of the device both AND and OR array can be programmable. Based on that we are classifying the programmable logic devices into 3 categories. Okay, so it consists of n input, k product terms. Okay, product term means AND terms, then m output term, that means sum term. ஓகே, இப்போ நான் ஒரு ஃபுல் ஆர்டர் எடுத்துக்கிறேன்னு வச்சுக்கோங்கப்பா. ஃபுல் ஆர்டர் எடுத்துக்கிட்டோம்னா நமக்கு ரெண்டு ஃபங்க்ஷன் இருக்கு, ரெண்டு அவுட்புட் இருக்கு. கரெக்டா? அப்போ மீனிங் என்ன? ரெண்டு சம் டேர்ம் எனக்கு வேணும். ஃபைன். ஓகே, அந்த ரெண்டு சம் டேர்முக்கு ப்ராடக்ட் டேர்ம் என்னென்ன வேணும்ன்றது யூ ஹாவ் டு டிசைட். சி ப்ராப்ளம்ஸ் பார்க்குறப்ப நான் சொல்றது எல்லாமே கிளியரா புரியும். ஆஸ் இட் இஸ் எ தியரிட்டிக்கல் கான்செப்ட், யூ ட்ரை டு அண்டர்ஸ்டாண்ட் வாட் ஐ எம் சேயிங். சி டு பெர்ஃபார்ம் எனி சர்க்யூட், டு பெர்ஃபார்ம் த லாஜிக் ஆபரேஷன் ஆஃப் எனி சர்க்யூட், you can go with sum of product. First you have to perform AND operation. So அதுக்கு AND array இருக்கு. என்னென்ன மின் டேர்ம்லாம் வேணுமோ அந்த எல்லா மின் டேர்மும் நான் என்ன பண்ணிக்கலாம்? By writing some program I can generate. So அதுல எதெல்லாம் நமக்கு OR பண்ணணுமோ we can do it. Or else I will show an example, give an example so that you can understand. ஒரு சின்ன எக்ஸாம்பிள் மட்டும் கொடுக்குறேன். So I am going to consider full adder. Okay, full adder னா எத்தனை இன்புட் இருக்கணும்? 3 inputs இருக்கணும் கண்டிப்பா. A B C. Okay, we must be having 3 inputs A B C. Okay, how many outputs we will be having? 2 outputs, sum, carry. Okay, fine. இப்போ இந்த AND array வச்சு நான் என்ன பண்ண போறேன்? என்னென்ன மின் டேர்ம்ல எனக்கு வேணுமோ அதை மட்டும் நான் ஜெனரேட் பண்ணிக்கலாம். சரி, ஃபார் எக்ஸாம்பிள் சம்முக்கு என்னென்ன மின் டேர்ம் சொல்லியிருக்கோம் ஞாபகம் இருக்கா? 1 2 4 7. ஓகே, அப்ப மீனிங் என்ன அப்படின்னு பாத்தீங்கன்னா A B C அதை வச்சு நான் என்ன பண்ண போறேன்? A பார் B பார் C பார். கரெக்டா? சோ 1 அப்படின்னா மீனிங் என்ன? 0 0 1 ன்னு எழுதலாம் கரெக்ட்டா for 1 I am writing 0 0 1 which is nothing but a bar dot b bar c. Like that I can have a product term under term for 2 2 க்கு என்ன வரும் a bar b c bar. What about for 7? It is a b c, simply a b c. So this is for sum. So sum க்கு நமக்கு என்னென்ன termல வேணும்? We require 4 min terms. 1 2 4 7. 1 na a bar b bar c, 2 na a bar b c bar, 4 means a b bar c bar, 7 means a b c. So இப்ப 4 under term இங்க கிடைச்சிச்சா அதே மாதிரி carry க்கு என்னென்ன சொன்னோம்? What are the min terms we have? 3 5 6 and 7. Fine. நல்லா கவனிக்கணும்ப்பா. ஆல்ரெடி இங்க 7ன்ற மின்டம் எனக்கு இங்கே நமக்கு தேவைப்படுது கரெக்ட்டா? சோ இங்கேயும் 7ன்ற மின்டம் நமக்கு தேவைப்படுது. Apart from that we need other 3 minterms 3 5 6. சோ இப்ப டோட்டலா எத்தனை under term வேணும் எனக்கு இங்க 7 under terms. You will be having many under array. சோ அப்ப 3 inputs நான் சொல்லிட்டேன். அப்ப ஒவ்வொரு AND கேட்டுக்கும் இன்புட் எத்தனை போகும் 3 inputs போகும். ஃபைன். சோ அந்த 3 inputs நான் என்ன பண்ணிக்கலாம் a bar b bar c bar அப்படினா min term 0 கிடைச்சிடும். ஆனா எனக்கு அது தேவை கிடையாது. சோ நான் என்ன பண்ணிக்கலாம் 1 2 3 4 5 6 7 இந்த 5 min term மட்டும் நான் என்ன பண்ணிக்கலாம் I think 1 2 3 4 5 6 7 min terms மட்டும் நான் ஜெனரேட் பண்றேன். ஃபைன். இந்த 7 min termsல இருந்து நான் என்ன பண்ண போறேன் ரெண்டு R array இருக்கு. ஒரு R array எதுக்கு to perform the sum operation. சோ இந்த 4 min term மட்டும் ஆட் பண்றதுக்கு இன்னொரு R array எதுக்கு to perform the carry operation. Carry outputக்காக இன்னொரு R array. சோ இப்போ இங்க எத்தனை இருக்கும் many under arrays will be there. By writing some program we can generate 7 min terms. Okay, அந்த 7 min termல எதெல்லாம் R பண்ண போறோம். சோ அப்ப எனக்கு இங்க என்ன இருக்கும் will be having many R array. அந்த R array ஓட சைஸ் எப்படி இருக்கும்னு பாத்தீங்கன்னா the number of under array out அத பொறுத்து இருக்கும். Fine. So we will see problem in next class. As of now you have to understand what generally a PLD is having. Okay. So types of PLD, 3 types of PLDs are there. Programmable read only memory, PROM. PROM பொறுத்த வரைக்கும் என்ன அப்படினு பாத்தீங்கன்னா I will tell you. Then programmable array logic, then programmable logic array. Kindly take a screenshot of this. We are having 3 types of PROM. 15th slide வேணுமாப்பா. Now only I am seeing the chat. Okay, kindly take a screenshot. Yes, have you taken the screenshot? Yes, okay. So we are having 3 types of PLDs. So the first type வந்து பாத்தீங்கன்னா PROM சொல்றோம். அடுத்து PAL, PLL சொல்றோம். கரெக்ட்டா? Fine. PROM பொறுத்த வரைக்கும் பாத்தீங்கன்னா in the case of PROM we will be having fixed under array. Fixed under array னா மீனிங் என்ன? கண்டிப்பா இங்க decoder யூஸ் பண்றாங்க. அப்ப மீனிங் என்ன? 3 inputs நான் கொடுத்துட்டாலே அவுட்புட்ல எனக்கு என்ன வந்துரும்? அவுட்புட்ல எனக்கு என்ன வந்துரும்? 8 under array இருக்கு. Okay, each under array எனக்கு எத்தனை இருக்கும்? AND gate எத்தனை இருக்கும்? 8 AND gates will be there. The number of AND gates collectively we call it as AND array. Clear? Array na meaning என்ன இங்க? Number of AND gates present. So அப்ப 3 input நான் கொடுக்கிறேன் அப்படின்னா எனக்கு என்னென்ன min termsலாம் இருக்கு? A bar B bar C bar. Fine. A bar B bar C up to ABC. இந்த 8 min termக்கும் 8 AND gate இல்ல. கரெக்ட்டா? So decoder circuit நம்ம ஆல்ரெடி டிசைன் பண்ணிருக்கோம். அதுல பார்த்தாலே நமக்கு தெரியும். So 3 inputs if I am giving 8 AND terms will be there. Number of AND terms is fixed. So AND array என்ன ஆயிடுது? Fix ஆயிடுது. Whereas R array you can program it. Next class la problem solve பண்ணலாம். At that time you can understand what I am saying. Fine. Is it clear for everyone? AND array fixed இருக்கும். R array வந்து program பண்ணிக்கலாம். இதுல PROM. Kindly take a note of it. I will move to next slide. In the case of PAL, PAL என்ன சொல்றோம்? Under array is programmable, R array is fixed. Under array மட்டும்தான் program பண்ண முடியும், R array fixed இருக்கும். That means அந்த R gate, say for example n R gate இருக்கு அப்படின்னா அந்த n R gateக்கு இத்தனை inputs தான் போகணும் அப்படின்றதெல்லாம் ஃபிக்ஸ் ஆயிடும். That means R array is fixed, under array we can program. எந்தெந்த மின்டம் வேணுமோ அதை மட்டும் ஜெனரேட் பண்ணிக்கலாம், but R array it is fixed. Okay, so this kind of devices can be used to implement any logic circuit. எந்த logic circuit வேணாலும் நான் என்ன பண்ணலாம், PLDs யூஸ் பண்ணி பண்ண முடியும். Okay, so here in the case of PAL, under array is programmable, R array is fixed. The last one is PLD. இதுல ரெண்டுமே programmable. Under array is programmable, R array is also programmable. Both under array and R array both are programmable. Fine. So with this we will stop today's theory session. We will continue to see answer key discussion. Okay. So with this slide I am going to stop the recording.